Have you ever noticed birds perched on high-voltage power lines and wondered why they don't get electrocuted? Despite sitting on wires carrying thousands of volts, these birds remain unharmed. The explanation lies in the principles of electricity and how current flows through conductive paths. Electricity requires a complete path or circuit to flow. Current will always move from a region of higher electrical potential to a region of lower electrical potential, usually through the ground. A bird sitting on a single power line does not provide such a path. Its body is in contact with only one conductor, and there is no significant difference in electrical potential across its body. Because there is no potential difference, very little, if any, current passes through the bird, preventing electrocution. To understand this further, it is important to discuss the concepts of voltage, resistance, and current. Voltage is the difference in electrical potential between 2 points. Current is the flow of electric charge, and it will only flow if a complete path exists between points of different potential. Resistance is the property of a material that resists the flow of current. In the case of a bird on a wire, the electrical potential across its body is effectively the same from beak to feet. Since there is no potential difference, the current does not flow through the bird. However, birds can be electrocuted if they contact two wires at different potentials, or a wire and the ground. In these cases, the bird's body provides a conductive path between points of different potential. Electrical current will flow through the bird from the higher potential to the lower potential, resulting in injury or death. This illustrates a fundamental principle. Safety depends on the presence or absence of a complete electrical circuit, not solely on the voltage of the line. It is also important to note that the size or mass of the bird does not significantly affect its safety. Both small birds, such as sparrows, and large birds, such as eagles, can safely perch on a single wire. The determining factor is the lack of a potential difference across the body. Similarly, even human contact with a wire at high voltage can be fatal if the person provides a path to ground. Standing on the ground while touching a live wire creates a complete circuit, allowing current to flow through the body. In addition to these natural phenomena, engineers take steps to minimize the risk of electrocution for birds and other wildlife. Power lines are designed with careful spacing between conductors to prevent animals from simultaneously contacting multiple wires. Insulators and protective devices are used to reduce the risk of accidental contact. In some regions, diverters and platforms are added to allow birds to safely perch or navigate near electrical infrastructure. These measures demonstrate an awareness of the intersection between natural behavior and human-made systems. Birds often utilize power lines as perching sites and sometimes build nests on transmission towers. These elevated structures provide safety from predators and a vantage point for observing their environment. The fact that birds can rest on these structures for long periods, even in adverse weather conditions, highlights the effectiveness of electrical principles in ensuring their safety. The phenomenon of birds remaining unharmed on high-voltage wires illustrates a fundamental concept of electricity. Current only flows along a path of difference in potential. Without a voltage difference across their bodies, birds do not experience the flow of electric charge. It is a simple yet profound demonstration of how natural behavior intersects with the physical laws of electricity. This understanding has practical applications not only in protecting wildlife but also in ensuring human safety and the design of electrical systems. It is a reminder that even complex systems like high-voltage transmission lines operate according to fundamental physical laws, and that knowledge of these laws allows both humans and wildlife to coexist safely within these systems. Thank you for watching. If you found this fascinating, hit like, subscribe, and ring the bell. You'll never look at the world the same way again.